For these problems, I'm going to be showing you today how to do an empirical formula challenge problem. For an empirical formula challenge problem, you actually know how to do almost all of the steps, but I'm just going to show you today how to put those steps together so you can solve the puzzle. For this particular puzzle, we're trying to figure out what mystery compound this is between phosphorus and oxygen. It says PXOY. And by the end of the problem, we're going to be able to figure out what that mole ratio is between the phosphorus and the oxygen. It tells us how much water reacts with our mystery compound to form some phosphoric acid, and it also gives us the mass of that. So just to help keep track of all the numbers, I'm going to put the numbers underneath the chemical it's talking about. So I'll put the 45.86 under the water, the 166.45 grams under the phosphoric acid. It tells us that the reaction is currently unbalanced. We're going to learn how to balance chemical equations soon, but not just yet. It also tells us to make the assumption that there are no excess reactants. What that means is when the reaction is done, there are no leftover reactants. So in this particular problem, the PXOY and the water are our reactants. The phosphoric acid is our product. So this is telling us that when the reaction's done, there is no more PXOY, there is no more water, it's just phosphoric acid. One of the key ideas that you will see in these problems is the law of conservation of matter, or the law of conservation of mass. Whatever you start with, you have to end with, because we can't create or destroy matter. So if we know that we ended with 166.45 grams worth of stuff, that means we had to have started with 166.45 grams worth of stuff. So my first step that I'm going to do here is I'm going to figure out what is the mass of my PXOY. How much reacted with the water? So in the end, we had 166.45 grams worth of stuff total. 45.86 of that came from the water, which means the difference between those two numbers would be how much came from our mystery compound. 120.59 grams of PXOY. I'm going to color code these elements for you to help you keep track of where everything starts and where it ends. So when you're looking at your phosphorus, it starts here in your mystery compound, but then it reacts with the water, turns into phosphoric acid. So all of that phosphorus on the left turns into this phosphorus that you see on the right. The hydrogen starts here in the water, and then it ends here in the phosphoric acid. So the only place the hydrogen goes is from the water to the acid. The oxygen's a little bit trickier though, because it starts in two places. Some of it's in the PXOY, some of it's in the water, but then they kind of merge together to turn into this oxygen that you see on the right-hand side. Because of that, because it starts in two places, ends in one, the oxygen's a little bit trickier. So I'm going to start my focus today on trying to figure out the phosphorus portion of our mystery compound. To do that, what I'm going to do is do a percent composition problem, not on my PXOY because I don't know how many phosphoruses or oxygens there are in my mystery compound, but I do know how many phosphoruses there are in my phosphoric acid. So I'm going to do a percent composition on my known chemical, the H3PO4, because if I could figure out how much phosphorus there is right here, and the only source of the phosphorus is here, we can kind of work backwards. If we know how much phosphorus we have in the end, we know how much phosphorus we had in the beginning. So let me do a percent composition on my known chemical. My known chemical has 3 hydrogens, 1 phosphorus, and 4 oxygens in it. I'm going to show you some light work so you can see where my numbers are coming from. So I'm just going to do a quick molar mass of my phosphoric acid. So the 1, the 31, and the 16 are all coming off of the periodic table. We add those guys up, and phosphoric acid has a molar mass of 98 grams. My next step in a percent composition problem, since I'm trying to figure out the phosphorus part of my mystery compound, I'm going to focus on that phosphorus here. Because however much phosphorus I have on the right, I'm going to have the same amount on the left. Well, if I had 98 grams of phosphoric acid, I'd have 31 grams worth of phosphorus. But I don't have 98 grams worth of phosphoric acid. I have 166.45. So let me see if I could do that percent phosphorus and apply it to how much phosphoric acid I have. So 31 out of the 98 grams worth of phosphoric acid comes from the phosphorus. That percentage is 31.6%. So any sample of phosphoric acid is 31.6% phosphorus. I happen to have 166.45 grams worth of phosphoric acid. So my next step is going to be to apply the percent composition to the mass of the known. So I know that I have 166.45 grams worth of phosphoric acid, and I know that 31.6% of that mass comes from the phosphorus. So I'm going to switch that 31.6 to a decimal, 0.316, and then multiply it by the mass of my known chemical, the phosphoric acid. That will tell me how much phosphorus is in my sample of phosphoric acid. 52.5982 grams of phosphorus are in phosphoric acid in our sample, the 166.45 gram sample. I'm going to keep a few extra decimal places for right now, because we are going to use these numbers later on in the problem. Well, now we know that if we have 52.5982 grams worth of phosphorus in our phosphoric acid, and the only source of our phosphorus was our mystery compound, doesn't that mean that we also have 52.5982 grams of phosphorus in our mystery substance? Because that's the only place where the phosphorus could have come from. And due to law of conservation of mass, law of conservation of matter, if you started with 52.5982 grams worth of phosphorus, you have to end with that much. Here is a key step that comes next that a lot of people miss, but it's really quite easy. Look for an easy subtraction problem. Could you do the same thing where you get a percent composition of oxygen and apply that to figure out how much oxygen is in your PXOY? Well, Well, remember saying how the oxygen was a bit complicated because there's two sources of the oxygen? So you'd have to subtract out the oxygen that comes from the water to get the part that comes from the mystery compound. It's not that you can't do it, it's just a little bit of extra work. So here's the key idea. Be on the lookout for an easy subtraction problem. You know right here that your mystery substance has a mass of 120.59 grams total. We're now trying to figure out how much oxygen weighs. But we know how much the phosphorus part weighs. Couldn't we subtract out the phosphorus part and then that would get us the oxygen part by itself? So if I have 120.59 grams of my mystery chemical, PXOY, and I know that 52.5982 grams of phosphorus are inside that mystery compound, wouldn't the leftovers be how much oxygen I have? 67.9918 grams of oxygen are in my mystery compound. The last step is one that you're familiar with, doing an empirical formula problem. You right now have a gram ratio. We want a mole ratio of PXOY. So couldn't we take those grams of phosphorus and grams of oxygen, switch them into moles of phosphorus and moles of oxygen? So I'm going to take that 52.5982 grams worth of phosphorus and my 67.9918 grams worth of oxygen, and I want to convert both of them into moles so I can get a mole ratio instead of a gram ratio. There's 31 grams of phosphorus in a mole of phosphorus. There's 16 grams of oxygen in a mole of oxygen. No sig fig rounding just yet. If we throw this in our calculator, we'd get 1.696716 moles worth of phosphorus for every 4.24948 moles worth of oxygen. We would then have to divide everybody by the little guy to get a small whole number ratio. So this one is the smaller of the two numbers. So I'll divide phosphorus by itself, and I'll also divide the oxygen by that same number. When we divide the phosphorus by itself, we get roughly 1 phosphorus for every 2.5 oxygens. But we can't have fractions in our final answer, so what we can do is get rid of that half by doubling our oxygen, turn that into 5 oxygens. If we want to keep everything proportional, I'd also have to double my phosphorus. So my final answer is P2O5. So in a nutshell, keep these ideas in mind. The law of conservation of mass is key. We used that at first to figure out how much PXOY we had in general. And then we used the law of conservation of mass again here, because if we knew how much phosphorus we had on the right-hand side, we have to have the same amount on the left. We also used it when we look at the finding the mass of the oxygen portion. You knew the mass of the whole thing, and you knew the mass of the phosphorus part. You can't create or destroy matter So whatever the difference is between those two numbers would be how much the oxygen part weighs. The percent composition of our known chemical allows us to find how much is in the mystery chemical. And then empirical formula from there on out. So you know how to do all these steps. It's just a matter of putting them in the right order and not forgetting any of the steps in that process. There's a worksheet that you guys are going to be working on in class to practice this idea a little bit. Good luck.